66 million years ago, Earth was unlike anything we know today. The continents had not yet taken their modern shape, oceans sliced across entire landmasses, and a vast inland sea split North America in two. The air was dense and humid, thick with warmth and life. The forests were endless, with trees that towered like giants, cloaked in moss and tangled with ancient vines. Beneath their canopies moved creatures so massive and strange that to the modern eye, they would seem mythological. This was the final chapter of the Age of Dinosaurs, and it was beautiful. On a warm afternoon, the lowlands near the coastline were alive with motion. Herds of triceratops lumbered through the tall cycads, their heavy footsteps pressing into the soft, wet earth. The adults walked protectively around their young, swaying their massive heads, each one crowned with a three-pronged shield of bone and horn. Their movements were slow and deliberate, the result of instinct honed through millions of years of survival. Nearby, in the murky underbrush, a pair of feathered predators, dromaeosaurs, stalked the edge of the herd, their sickle-shaped claws barely making a sound against the leaf-littered ground. They didn't attack, not yet. They were waiting for a mistake, for a calf to wander too far, or for one of the older animals to fall behind. Patience had always been the predator's greatest weapon. In the sky above, pteranodons rode the thermals, gliding on wings as wide as trucks. Their long, beaked skulls scanned the ground for carrion fish or smaller prey. They made no sound except the occasional leathery rustle as they tilted against the wind. They had ruled the skies since before any dinosaur walked the earth. They had no reason to suspect their reign was ending. And then, in the shadows of the forest, the trees parted for something far larger. It moved with the silence of a stalking lion, yet every step it took made the ground tremble. Its skin was a patchwork of scars and scales, its body more than 40 feet long from snout to tail. With jaws strong enough to crush bone and a bite unmatched in the animal kingdom, it was the ruler of this domain. Tyrannosaurus rex, apex predator, king of the dinosaurs. The great beast paused at the edge of the trees, its eyes the size of baseballs fixed on the open plain. A warm breeze carried the scent of prey. It sniffed once, slow and deliberate, then it waited, still, watching. None of them knew. In the vastness of space, somewhere beyond the moon's orbit, something ancient was falling toward Earth. A traveler from the depths of the solar system, 6 miles wide, black as coal, and older than our planet itself. It had no name, no mind, it carried no heat, no fire, only momentum. Its surface was jagged, a broken fragment of a forgotten world. It had wandered space for hundreds of millions of years, pulled by gravity, nudged by distant collisions, until at last its path intersected with our own, and now it was only 1 hour away. Back on Earth, life continued unaware. In the warm shallows of the inland sea, great marine reptiles swam lazily through forests of coral. Massive turtles paddled through the currents, and ammonites, shelled creatures that had survived 5 mass extinctions before this, drifted like jellyfish across the ocean floor. In a coastal lagoon, a group of small mammals rooted through the underbrush, searching for seeds and insects. They were no larger than rats, barely noticed by the dominant reptiles. But their time would come. In the ruins of a dying world, they would rise. But for now, they simply scurried, blinked, and lived, unaware that history was moving beneath their feet. Somewhere in the skies above, invisible to every creature, a bright speck had appeared. It grew larger with each passing second, though no eye on Earth could see it clearly yet. To a human observer, it might have looked like a star falling out of place. But there were no humans to witness it, no telescopes, no warning systems, no satellites to detect the oncoming impact. The planet spun on. The winds whispered through ancient forests. The sun warmed the backs of cold-blooded giants, and insects buzzed in swarms through the canopy. Life did not pause. It didn't flinch or run. It couldn't. It didn't know. At the base of a cliffside river, a hadrosaur, a duck-billed dinosaur with a crest on its head, dipped its snout into the water. It drank slowly, its tail swaying lazily behind it. Fish scattered at its approach, frightened more by the tremors than the predator itself. The hadrosaur looked up for a moment, sensing something, but it was nothing it recognized. Just the wind. Elsewhere, deep in the ocean, a mosasaur, the terror of the seas, rolled through the water like a torpedo. Its jaws opened wide, revealing rows of curved teeth designed to grip slippery prey. It chased a school of fish, its tail pounding the water with explosive force. It didn't know the currents would soon turn acidic. That darkness would descend upon the ocean like a curtain. Nothing new. The asteroid was closing in fast now at over 20 kilometers per second. Faster than a bullet, faster than sound, faster than comprehension. Its impact would release energy greater than every nuclear bomb ever built by humankind, combined. A blast so powerful it would set the sky on fire, boil the seas, and shake the Earth's crust. But for now there was only calm. Somewhere in what is now the Yucatan Peninsula of Mexico, the sun sparkled over the waves. The beach was quiet, save for the rustling of wind through palm-like trees and the cries of distant reptiles. It was just another ordinary day. The asteroid's shadow had not yet touched the Earth, but its presence was written in the stars. Scientists today know it was rich in iridium, a rare element rarely found in Earth's crust, but common in asteroids. When the rock struck, it would send that iridium soaring into the sky, a signature that would remain buried in the layers of our planet's history, a quiet fingerprint of an apocalyptic moment. Why that day? Why that asteroid? Some theories suggest it was gravity, Jupiter, the great gas giant, pulling celestial objects into slingshot trajectories. Or perhaps it was coincidence, a collision long ago in the asteroid belt that set this single rock on a journey it could not deviate from. A journey that would end, not with a whisper, but with a flash bright enough to light up the entire hemisphere. And yet, here on Earth the countdown continued, unnoticed. A dragonfly skimmed the surface of a pond. A young pterosaur practiced flight along the cliffs. A predator hunted. A mother cared for her young. A heartbeat echoed in the ribcage of a creature that had never once felt fear from the skies. 50 minutes to go, still no sign, still no sound. Just the slow turning of a planet filled with life, perfectly balanced, unaware of the cosmic imbalance hurtling toward it. For the dinosaurs there had been no golden age, no prophecy, no warning. Their world wasn't ending in fire just yet. For now, it still belonged to them. But the rules were about to change, and none of them could know that this was their final hour. Chapter 1. 1 hour before impact. The calm before extinction. The morning sun pierced the canopy in golden shafts, filtering through the towering conifers and the giant cycads that had stood rooted for hundreds of years. The forest floor steamed with warmth, its ferns reaching out like green lace under the thick humidity that pressed down from the sky. In the western interior of what would one day be North America, there was no sense of looming doom. The earth was not trembling, the sky was not yet weeping fire. In this final hour, life thrived without hesitation, unaware that time itself was running out. A herd of triceratops lumbered slowly through a shallow valley, their heavy footsteps muffled by soft soil and decaying plant matter. Each step sunk slightly into the mud, as if the land was trying to cling to them, trying to hold on. Their horns were coated with the remnants of morning dew and sap from pushing through dense brush. Massive beaks snapped off ferns in wide chomps, their jaws moving side to side to grind the thick vegetation. Adults flanked juveniles in tight formation, a social bond that was stronger than chance. The largest females paused often, lifting their massive heads toward the wind. Nostrils flared, ears twitched. The scent of something distant lingered in the air, but it was not the smell of ash or fire, not yet. Not. Farther out, between the fingers of ancient rivers and near the shores of an inland sea that once divided the continent in two, other giants moved like slow titans. Alamosaurus, long-necked, thick-legged and towering like walking skyscrapers of flesh, moved in loose herds through the open floodplains. Their tails swung in wide, lazy arcs, a language unto themselves. Each step left deep impressions in the mudflats, soon to be trampled by others in their wake. They were not alone. Near their feet scurried smaller creatures, bird-like dinosaurs with feathers like modern herons or crows, darting between trunks, snapping up beetles and ancient crickets that hummed and clicked in the heat. Above them all, a shape cut across the sky. Its wings cast a fleeting shadow over the canopy. It was not a bird, though it had once been mistaken for one in the early days of fossil discovery. It was a Quetzalcoatlus, a flying reptile with a wingspan wider than a fighter jet. It rode the warm thermals, its sharp eyes scanning the land for carrion or the movement of small prey. With a slender beak that could pierce flesh or scoop up a baby dinosaur in one swift strike, it was a master of the skies. Yet even it, high above the land, saw no danger, no warning, no reason to believe the world below would soon turn to ash and bone. The western interior seaway stretched before it like a shimmering mirror, reflecting sunlight in waves that danced across the surface. This inland ocean was warm, shallow, and teeming with life. Giant turtles, some nearly the size of small cars, swam slowly just beneath the waves. Predatory marine reptiles, mosasaurs with jaws built like bear traps, prowled the depths. Fish with armor-plated scales glimmered in schools that flashed silver and blue, their movement hypnotic and ancient. The smell of salt, rot, and algae hung in the air, mingling with the buzz of insects and the distant thunder of herbivore herds on the move. Yet even here, where creatures had adapted to every niche, from the marshes and deltas to the open ocean, no one looked up to the stars. No one could see the faint glimmer in the sky, still thousands of miles away, approaching silently at 20 times the speed of sound. If any of them had looked westward at the right moment, perhaps at sunset, they might have seen something strange, a light, brighter than any star, briefly appearing just above the horizon. But it would vanish too quickly, just a trick of the eye, a comet, a meteorite, and besides, it was daytime now, and the sky was a brilliant pale blue. The forest ecosystems were rich and complex. Flowering plants, angiosperms, were rising in dominance, outcompeting their older cousins like cycads and ginkgos in many regions. Bees buzzed through the undergrowth, pollinating petals that would soon give rise to fruits never eaten. Dragonflies with wingspans as long as a man's forearm zipped through shafts of light. Some of the first true birds, like Ichthyornis and Hesperornis, darted along the coastlines or dived into lakes after fish. This was a world on the brink of something new. Evolution had already planted the seeds of mammals, birds, and flowering forests. It was as if nature was preparing to pass the torch, though it didn't yet know it. On the edge of a mangrove swamp, a lone Tyrannosaurus rex stood still, its head tilted slightly to the side. It had picked up a scent, faint, but familiar. Its nostrils flared, drawing in chemical signals from half a mile away. It was not hungry. Not yet. But its instincts were always alert. With each breath, it could detect changes in humidity, pheromones from prey, or even the distant presence of rivals. Its massive jaws opened slightly, revealing rows of serrated teeth, stained with the memory of its last kill. Every movement was calculated, deliberate. The weight of its foot pressed softly into the loam as it stepped forward. Not in a charge, not in a run. Just a slow, surveying stalk. Somewhere in the distance, a juvenile Edmontosaurus bleated, calling to its mother. Its voice echoed across the flatlands, but no one answered. The young hadrosaur stood alone, ears twitching, eyes wide. It didn't know it yet, but it had wandered too far from the herd. Its instincts told it to stay still, to freeze. But curiosity often outweighed caution in the young. As it stepped forward to call again, a faint tremor passed through the ground. So subtle that it might have gone unnoticed, mistaken for the movement of nearby giants or the distant rumble of the seaway tides. But it wasn't. It was the first whisper of something far, far worse. High above the planet, 66 million years removed from human eyes, a 6-mile-wide asteroid tore through space with the power of 1 million nuclear bombs. It had already crossed the orbit of Mars, and now screamed toward Earth with no intention, no reason, no malice. It was older than Earth itself, a fragment from the violent formation of the solar system, a survivor of cosmic collisions, bearing the fingerprints of long-dead planets and lost moons. As it raced toward the Yucatan Peninsula, it had no awareness of the consequences. It simply moved, as all things do in space, blindly, governed by gravity and time. Back on the ground, a pair of dromaeosaurs darted through the ferns chasing a lizard-like reptile that zigzagged wildly to avoid capture. Their feathers shimmered slightly in the light. They moved with bird-like grace, intelligent eyes locking on their prey. These were predators built for agility, swift, coordinated, clever, and yet, like everything else on this continent, their fate was already sealed. Every chase, every call, every breath they took now existed within the final grains of sand in an hourglass that had nearly run dry. Farther north, near the uplands and volcanic ridges, the climate grew harsher. The air thinned slightly, the flora changed. Here, thick forests gave way to open plains and ancient rivers. Herds of ankylosaurs, armored like tanks with clubs on their tails, moved slowly through these regions, digging at roots and chewing on low-hanging leaves. They were not fast, not built for running, but they were survivors, built for defense, not speed, built for a world that had once been far more hostile, but not for what was coming. What was coming could not be outrun, could not be armored against, could not be outwitted or avoided. In the oceans, coral reefs flourished with life. Ammonites swam in elegant spirals, their delicate shells reflecting light like pearls. They had survived extinction events before, endured chaos, recovered, thrived, but this time would be different. Tiny plankton, the base of the food web, floated in clouds beneath the surface. They were the silent foundation of the ecosystem, and in less than an hour nearly all of them would vanish. The Earth was not unaware, even if its inhabitants were. Deep in the mantle, the planet's magnetic field began to pulse strangely. Something in the upper atmosphere caught the first traces of heat, the barest whisper of friction. Satellites, if they had existed, would have detected a slight infrared signature above the Pacific. A strange flicker, an anomaly. And yet, in the western interior seaway, the turtles continued to swim, the fish continued to spawn, the Alamosaurus kept grazing, the Tyrannosaur kept hunting. Time had not stopped, it was moving forward, relentlessly, toward the moment that would split Earth's history in half. In this final hour before the impact, the world did not scream, it did not panic, it lived, because it didn't know. But if nature had a voice, if the trees could whisper, or the wind could carry warning, what would it say? Would it cry out to the creatures of the forest and the deep? Would it plead for one last chance? Or would it remain silent, dignified, until the very end? And if it could speak, would it also wonder what exactly was coming from the sky, and why now? The world had no warning. It was late morning in the lush Cretaceous tropics. The sun climbed through a haze of mist, lighting up a vibrant world teeming with life. Along the coastal plains, herds of horned dinosaurs grazed quietly. Overhead, ancient skies shimmered with the wings of enormous flying reptiles drifting lazily on thermal updrafts. Deep inland, forests whispered with the movements of predator and prey, their rhythm uninterrupted for millions of years. There was no sound of alarm, no tremor in the ground. Nothing yet hinted that at this very moment, something unspeakably ancient and catastrophic was rushing toward them from the stars. In the final seconds, the object became visible. A furious fireball brighter than the sun, slicing across the sky. But by the time its glow reached the surface, it was already too late. The asteroid, roughly 6 to 7 miles wide, struck with a force that defies comprehension. It was not a simple collision. It was a moment of instantaneous world-shattering transformation. The impact occurred in what is now the Yucatan Peninsula of Mexico, then a shallow, warm inland sea. The asteroid smashed into the Earth at over 40,000 miles per hour, compressing the atmosphere beneath it and superheating the air to temperatures hotter than the surface of the sun. In a flash, the ocean boiled away, rock turned to vapor, an enormous cavity blasted open in the crust. The entire region, hundreds of miles in every direction, was instantly obliterated. The force of the impact released more energy than every nuclear bomb humanity would ever create. 100 million megatons of energy burst forth in a single second. A shockwave of compressed air surged outward faster than sound. Anything within 1,000 miles was flattened. Trees did not sway. They vanished. Forests ceased to exist. Creatures were flung through the air like dry leaves. Some disintegrated before they could even comprehend the sudden brightness. The heat alone near the impact zone was so intense that it could ignite flesh from bone. Nothing survived. The Earth groaned under the pressure. A global earthquake, greater than magnitude 10, rippled through the crust, sending cracks racing through the tectonic plates. Landslides were triggered across continents. Underwater, faults shifted violently, releasing tsunamis over 1,000 feet tall. Waves surged inland at hundreds of miles per hour, devouring coastlines and reshaping the geography of entire regions. At the heart of the impact, molten rock and pulverized earth were blasted upward, forming a towering column that punched through the stratosphere. Debris from the earth itself, shattered rock, vaporized sulfur, and molten droplets called spherules, was hurled into space before falling back through the atmosphere, raining down across the planet like bullets. The friction from their re-entry superheated the sky. In many parts of the world, the sky quite literally caught fire. Animals hundreds or thousands of miles from ground zero began to die, not from the blast but from the firestorm. Trees ignited. Plants wilted in minutes. Entire ecosystems, once lush and green, were consumed by flames that stretched from horizon to horizon. There was no escape, not even in burrows or deep lakes. The temperature of the air itself became a killer. Yet, incredibly, this was just the beginning. The worst was yet to come. As the fireball faded and the tsunami receded, the sky began to change. A thick haze spread across the planet, darkening the sun. The vaporized rock and sulfur from the impact formed a shroud that wrapped the earth, blocking light and plummeting temperatures. For now, the initial chaos had cracked the planet like an egg, and life teetered on the brink. At this very moment, across the globe, countless species were simply unaware that their world had already ended. Massive herbivores still moved through distant jungles. Apex predators still stalked prey in shadowed valleys. Insects still danced above ponds untouched by flame. But soon, they too would feel the slow, creeping hand of extinction. The asteroid didn't just kill by fire, quake, or wave. It rewrote the planet's chemistry. The rocks in the Yucatan region, rich in sulfur and carbonates, vaporized on impact and combined in the atmosphere to form vast clouds of sulfuric acid. These aerosols reflected sunlight, initiating a sudden and severe drop in global temperatures. Within days, photosynthesis faltered. Within weeks, food chains began to unravel. It would arrive quietly, like a final aftershock to the initial apocalypse. For now, the Earth was still reeling. The crater left behind, over 110 miles wide and more than 12 miles deep, was filling with molten rock. Around it, devastation stretched for thousands of miles. But somewhere far from this epicenter, a family of triceratops might still be alive. A young tyrannosaurus might still be hunting. A small mammal might still be tucked in its burrow, shielded by sheer luck and soil. Life had not yet grasped what had occurred. The survivors were few, and they were scattered, but they were alive, for now. As darkness began to fall unnaturally early across vast swaths of the planet, the fire in the sky dimmed to a glowing smear of red and ash. A hush fell, a silence unlike any before. It was the quiet not of peace, but of something gone terribly wrong. The air smelled burned. The wind carried soot. Even the oceans, usually indifferent to the affairs of land, frothed with the turmoil of tsunamis still racing outward. And somewhere, in the cooling evening of this shattered world, a new question began to emerge. Not what had happened, that would soon become obvious to every creature still breathing, but rather, what would happen next? Because the impact was only the opening act. The true extinction had yet to unfold, and it would not be fire or wave or wind that claimed the Earth's dominance. It would be something much slower, much colder, much darker. The question that lingers like the falling ash is this: if the dinosaurs survived the initial blast, and many did, what was it that truly brought them to extinction in the days and months that followed? The world did not end all at once. It ended in waves. 10 minutes after the impact, Earth was quiet, but not in peace. The sound of the initial blast had raced around the globe like thunder, echoing through valleys, canyons, and inland seas. The tsunamis had begun their long march across oceans. Forests lay flattened or scorched in rings radiating out from the point of impact, yet in many places the chaos had not yet arrived. Animals stood frozen in confusion, sniffing the air, staring at a sky that was no longer the same. Above them, the true horror was just beginning. High in the upper atmosphere, trillions of tons of molten rock and vaporized earth had been launched during the impact. Some pieces had reached the edge of space. Now, gravity pulled them back. One by one, then in a steady torrent, they began to fall. This wasn't gentle ash drifting from a distant volcano. These were droplets of rock, superheated, molten, glowing with the heat of re-entry. As they screamed back through the atmosphere, they created friction, unimaginable friction. And as millions became billions, the sky turned into a furnace. The temperature across the planet began to rise, not from the sun, but from above. The sky itself became a source of heat. For hours, infrared radiation poured downward. Plants didn't wither slowly. They combusted. Leaves curled into flame without a spark. Branches exploded into fire with no warning. Forests ignited all at once like paper thrown into an oven. It was not a local phenomenon, it was global. From the great temperate forests to the swampy lowlands, fire spread not by contact, but by radiation. The very air became hot enough to trigger combustion. Dinosaurs that had fled the quake or outrun the wave now found themselves surrounded by walls of heat. They ran, but where could they go when the heat came from the sky itself? Herbivores collapsed mid-stride, their lungs burning from superheated air. Predators howled in agony as their flesh blistered and their feathers or scales shriveled. There was no safety in the open, and even the dense forest offered little protection. Firestorm Earth had arrived. Smoke began to blanket the land, thick and choking, black with the scent of burning biomass. Plants that had flourished for millions of years, towering cycads, vast conifer forests, newly evolved flowering shrubs, now fell in waves. The forest floor hissed as roots burned underground. The carbon in the air climbed to levels never seen before or since. Later in the distant future, this moment would be captured in the carbon-rich layers of sediment found across every continent. A dark fingerprint of apocalypse. But this rain of fire didn't just touch land. Near the coasts, life in the shallow seas faced a new kind of agony. As the falling debris heated the air, it also warmed the surface of the oceans. Shallow waters, once teeming with ammonites, fish, early corals, turned into boiling death traps. Creatures near the surface were parboiled alive. Their bodies floated to the top in layers, eyes cooked, organs ruptured. The thermal shock sent shock waves through marine ecosystems. Reefs collapsed. Coastal nurseries became cemeteries. And still, the rain continued, for hours. The falling debris, known to scientists today as spherules, didn't simply rain once and stop. They came down in waves, each heating the atmosphere a little more. By the time it was over, temperatures on the surface had likely reached over 1,000 degrees Fahrenheit in many regions, hot enough to melt lead. This was not just an impact, it was a planetary oven turned on full blast. Shelter became the only key to survival. Some small mammals, reptiles, and burrowing animals managed to find refuge underground, where the soil blunted the sky's wrath. In lakes deep enough, water absorbed the heat before it could reach the benthic zones. But these safe pockets were few, scattered like rafts in a sea of fire. The dinosaurs, so dominant just minutes earlier, now faced a crisis they couldn't understand. Many of them perished in minutes, not because they were weak, but because their world had simply become incompatible with life. There was no time to adapt, no way to run, no evolution fast enough to save them. The smoke, the ash, and the fire wrapped around the globe like a death shroud. The wind carried soot across oceans. The rain, when it finally came, was laced with acids formed from sulfur released in the impact. The rivers turned black with runoff from the charred land. The skies darkened not just with night, but with a veil that would remain for months. And under that veil, the earth waited. As the heat finally began to subside, a strange silence returned. The forests had been reduced to ash. The creatures that once roamed in the millions were now bones buried in blackened earth. The survivors were hidden, quiet, shaken. The world had passed through fire, but the worst was not over. What came next would not be fire or explosion or impact, it would be a long, slow silence. A darkness that would strangle what little was left. But as that darkness loomed, a question hung in the air like the smoke above the dead forests. Why did some creatures survive this inferno when so many perished? How did a handful of tiny mammals and birds live through a firestorm that silenced giants? The firestorm had passed. The skies above Earth, once blue and vast, now churned with something darker than night itself. Where once the world had breathed heat, chaos and flame, a new enemy had begun to rise. Not a visible monster, but a slow, creeping killer of cold and silence. The asteroid that struck the Yucatan Peninsula did more than shatter continents or boil seas. It had ejected over 100 billion tons of pulverized rock, superheated vapor and sulfur-laced dust into the stratosphere. For a fleeting moment, Earth was brighter than the sun. Then, it dimmed, and it would not brighten again for years. From the far corners of the Earth, across the steaming remnants of scorched forests through valleys once green and thick with life, a silent snowfall began. But this was no ordinary snow. It did not bring peace, or promise rebirth. It was ash. Microfine particles of dust, chemically charged by the violence of the impact, began drifting downward like a shroud. In the oceans, once lit by dappled sunlight that danced across coral reefs and glided over the backs of ammonites, darkness fell. Photosynthetic plankton, the very foundation of the marine food web, struggled. Light no longer reached the upper layers of water. With it went the energy that powered nearly every living thing in the sea. Above the land, temperatures began to fall, fast, with sunlight blocked by a blanket of soot and sulfate aerosols suspended high above the troposphere. The radiant warmth of the sun could no longer reach the ground. Within days, average global temperatures dropped by over 15 degrees Celsius. In weeks, they fell further. In months, even the equator began to freeze. Dinosaurs had survived droughts. They had endured changing seas, volcanic winters, even shifting climates. But this was different. The world itself seemed to stop. Herbivores, the great consumers of the Cretaceous, began to perish first. With photosynthesis interrupted, plants stopped growing. Leaves withered, fruit failed to ripen, entire forests stood ghostly and still. Some species like the hadrosaurs, dependent on large volumes of plant material to sustain their massive frames, began starving. In the fossil record, this decline is not gradual, it's abrupt. Skeletons show thinning bones, signs of malnutrition. In some regions, they vanish from the record entirely within months of the impact. Without prey, predators followed. Tyrannosaurus, apex of the terrestrial food chain, would have struggled to find enough meat to support its body. Starvation made them desperate, perhaps even turning to cannibalism. There is evidence in fossilized bones of tyrannosaurs bearing bite marks from their own kind. But the air carried more than dust. The asteroid had slammed into a bed of gypsum, a mineral rich in sulfur. That collision sent vast clouds of sulfur dioxide into the atmosphere. These molecules reflected sunlight even more effectively than dust and ash. Worse, when sulfur mixed with atmospheric water vapor, it formed sulfuric acid. Then came the acid rain. Across continents, rainfall turned toxic. Not just dangerous to drink, but chemically corrosive. Raindrops burned plant tissue. Thin-skinned amphibians, already sensitive to changes in pH, began to vanish. Freshwater lakes turned acidic, killing off fish and aquatic invertebrates that had lived undisturbed for millions of years. Coral reefs, already stressed by the rapid cooling, began to bleach. The delicate balance of marine life, built over hundreds of millions of years, began to fracture. In the cold, dark oceans, plankton collapsed. Without them, filter feeders like ammonites and many species of mollusks could no longer find food. And with their death, predators like mosasaurs and ichthyosaurs, the sea's top hunters, followed them into extinction. The fossil record doesn't lie. A thin band of clay, laced with iridium, an element rare on Earth but common in asteroids, marks this moment in geological time. Below it, fossils, diversity, life. Above it, a dramatic reduction in complexity. It is the boundary of the Cretaceous and the Paleogene. It is a tombstone written in dust. And yet not all life vanished. In burrows beneath the frozen Earth, small mammals huddled in nests insulated by soil and fur. They fed on roots, fungus, or whatever scraps remained. Some could hibernate. Others, like primitive shrews, had fast metabolisms that adapted quickly. Insects survived too, those that fed on decaying material or could reproduce rapidly. Crocodiles and turtles, shielded by their aquatic environments and cold-blooded physiologies, endured. And in the skies, some birds, descendants of the smaller theropod dinosaurs, managed to scrape by, eating seeds or scavenging. But they were few. In total, over 75% of all species on Earth vanished. On land, in the air, and in the oceans, ecosystems collapsed like dominoes. The age of dinosaurs had ended, not in a slow fade, but in a brutal, freezing silence. And yet, in the blackness, there was potential. From the ashes of extinction would rise a new world, a world without the thunder of sauropods or the roar of tyrannosaurs, but one that would eventually be ruled by the tiny, the adaptable, and the clever. Still, there's one haunting question the fossil record cannot answer. If the asteroid had struck a different spot, not the sulfur-rich shallow sea of the Yucatan, but deep ocean or solid ground, would the world have ended the same way? Or would the age of dinosaurs still reign? That question lingers like the ash that once blotted out the sun. The world after the impact was no longer a place for giants. It was a realm transformed by ice, darkness, and an endless veil of ash. The thunder of tyrannosaurs and the vast herds of hadrosaurs were silenced. But life did not surrender. It clung stubbornly to existence in the crevices of a broken world, in the cold shadows beneath ash-choked skies. Among the creatures that survived, the crocodiles stood as living testaments to resilience. These ancient reptiles had faced extinction threats before, but this was unlike anything before. Their heavily armored bodies, built for stealth and power in water, served as a natural shield against the worst fires raging across the land. Unlike many land animals, crocodiles could retreat deep into rivers, lakes, or swamps where the water protected them from burning embers falling like deadly rain. Their metabolism gave them an advantage too. Crocodiles can enter a state of torpor, drastically lowering their energy needs. For days or even weeks, they can survive with little to no food, waiting out lean times. In the immediate aftermath of the impact, when forests were flattened and prey was scarce, this ability likely saved them from starvation. Birds, the descendants of small theropod dinosaurs, were among the few dinosaurs to survive. They were small, light, and fast, able to navigate the increasingly hostile terrain with an advantage others lacked. Their feathers, once adapted for warmth and flight, may also have helped shield them from the cold and acidic rains. Their diverse diets made them more flexible than the large meat-eating dinosaurs. Some could feed on seeds dropped by the surviving plants, others hunted insects or scavenged carcasses. Their mobility allowed them to escape local disasters, migrate to safer areas, and exploit new habitats quickly. But it was the mammals, often overlooked in the shadow of giant dinosaurs, that held the key to the future. At the time, mammals were small, often no larger than modern rats or shrews, and nocturnal. Their tiny size was a survival advantage in a world starved for resources. Smaller bodies require fewer calories, fewer resources, and allow animals to hide more easily from predators and environmental dangers. Most crucially, mammals were able to burrow or find shelter underground. While firestorms raged and acid rain fell from poisoned skies, the earth beneath remained a refuge. In their burrows, mammals could avoid the worst of the environmental extremes: the suffocating smoke, the scorching heat, the freezing cold. These underground shelters buffered temperature swings, protected against radiation, and provided a place to hide from predators. The diversity of diets among mammals was another key to survival. Some mammals fed on insects, which could thrive on decaying organic matter, others scavenged, a few were early omnivores, able to eat seeds, fruits, or fungi. This flexibility allowed them to exploit whatever food sources remained after the widespread plant die-off. Mammals' ability to reproduce quickly also helped. Their shorter gestation and life cycles meant they could bounce back faster than the giant reptiles, whose slow growth and long reproductive cycles were liabilities in a rapidly changing world. In the fossil record from shortly after the impact, tiny mammal bones appear in increasing abundance and variety. Creatures like Didelphodon and Purgatorius scurried through ash-covered forests, exploring new ecological niches left vacant by the extinction of larger animals. This rise of mammals was not just survival but evolution in action, a reshaping of life itself. In the shadow of disaster, the small and adaptable flourished. Yet the question remains, did mammals survive simply because of luck, being small and underground when the asteroid struck, or were there deeper evolutionary advantages that gave them the resilience to not only survive, but thrive in a world without dinosaurs? And what can their survival tell us about resilience and adaptation in the face of planetary-scale catastrophes? Could lessons from their survival help us understand life's future on an ever-changing Earth? The fires had smoldered into ash. The skies remained dim, like twilight trapped in a bottle. But the rage of the initial cataclysm had passed. Earth had survived. It did not look like the same planet. Charred forests stretched for miles, the bones of the dead half buried in soot and cooling lava. Rivers once bustling with reptiles and amphibians now ran black with sediment and rot. But beneath the ash and silence, the first breaths of recovery had already begun. The first organisms to reassert themselves weren't mighty creatures. They were small, silent, persistent. Algae, lichen, fungi. In the hours after the impact, these primitive lifeforms became the quiet rulers of a broken Earth. With sunlight still partially blocked, and nutrients raining down in the form of pulverized rock and carbon, algae found a strange new opportunity in the aftermath. The waters, once warm and clear, now darkened with ash, were quickly overtaken by blooms of microscopic green. They flourished in nutrient-rich runoffs from burned forests and disintegrated soil. Across the shallow seas and lakes, algae exploded in number. Their rapid reproduction filled aquatic ecosystems with the first green shimmer since the sky went black. But it was fungi that truly inherited the land. In a world where most of the organic matter now existed as dead flesh and fallen trees, fungi had everything they needed. They broke down carbon, fed on decay, and turned death into nutrition. Vast mycelial networks silently spread under the surface, unseen but omnipresent. Spores drifted like fine powder across continents carried by wind currents that no longer rustled trees. Entire forests were repopulated not by leaves but by mushrooms, pale waxy growths pushing up through the layers of soot. We see this fungal takeover preserved in the rocks. Sediment layers right after the impact are filled with what scientists call a fungal spike, a dramatic increase in fossilized spores and fungal remains. It was as if the Earth itself had gone moldy in its grief. Among the first plants to rise again were the ferns. Hardy, ancient, and incredibly adaptable, ferns don't rely on seeds but spores, which are lighter, faster, and more widespread. These spores floated across the dead continents, settling in the cracks and crevices of scorched earth. And then, they grew. From the blackened soil, green tendrils began to uncurl, fronds stretching toward the faint sunlight. Their appearance in the fossil record is so sudden and dramatic that paleobotanists call it a fern spike. In layer after layer of post-impact sediment, fossilized fern spores dominate the landscape. It was like nature's declaration that life was not done, that after the fire, there would be growth. These first waves of plant life didn't look like the lush forests of the late Cretaceous. There were no tall conifers, no flowering trees heavy with fruit, no underbrush filled with colorful blossoms. This was a pioneer's world. Scrubby ferns, mosses, and small shrubby plants pushed up through ash, creating patches of green that slowly spread. As the plants returned, so did the animals. Not the towering titans of old, but the tiny survivors of a world gone dark. The mammals emerged cautiously at first, scurrying through the ferns, foraging for anything edible. Insects that had survived the fires were among the first prey. The mammals, still small and nocturnal, had lost their dinosaurian oppressors and found an empty world rich with opportunity. There were no tyrannosaurs now to send them fleeing. No hadrosaurs to trample over the shrubs and steal the best fruits. Suddenly the entire world was an open field of empty rolls, and they adapted quickly. Some mammals became diggers, using strong claws to burrow deeper and create new underground homes. Others became climbers, scaling the fragile skeletons of dead trees in search of insects. Some developed broader diets. Anything to make use of the sparse, inconsistent food sources in a still recovering biosphere. Birds followed similar paths. Those that had survived were typically ground-dwelling or forest edge flyers. With forests gone, open areas spread like deserts of ash, and ground foragers began to dominate. Some birds began filling niches left behind by smaller dinosaurs, pecking at carrion, picking through insects, and eventually evolving toward predatory or omnivorous habits. But something else was beginning to shift. The predators were returning. Without apex dinosaurs to rule the ecosystems, a new arms race began. One based not on size but on intelligence, agility, and adaptability. Early carnivorous mammals like the genus Didelphodon began experimenting with diets that included meat. Some became agile hunters of insects, amphibians, and even small reptiles. They were not large, but they were fast, warm-blooded, and increasingly social. Small crocodilians emerged from muddy waters to reclaim territory, feeding on fish and anything unfortunate enough to enter their domain. Turtles, those ancient slow-moving survivors, continued their quiet march through the centuries, unchanged but persistent. And then there were the fish. Many marine ecosystems had collapsed during the impact, plankton had died en masse when photosynthesis halted, and food chains in the sea disintegrated almost overnight. But in freshwater rivers and lakes, sheltered from the open ocean's turbulence, some fish endured. These freshwater survivors would later repopulate the seas, but for now, they remained hidden, biding their time. The earliest predator-prey dynamics of the post-impact world were humble but critical. Insect populations, though damaged, bounced back swiftly due to their fast life cycles. Flies, beetles, ants, all played a role in decomposing the dead and fertilizing new growth. In turn, mammals and birds that fed on insects saw population booms. This tight loop, of detritus insect and predator, became the foundation of new ecosystems. Where once towering giants ruled with brute force, now the web of life depended on nuance, resilience, and speed. Over years the atmosphere cleared slowly, rain carried the ash and dust into rivers, lakes, and oceans, skies began to open, sunlight filtered back through, faint at first, then stronger. With the light came more plant life. With plants came herbivores, and with them, the predators began to grow larger, smarter, more specialized. The earth was healing, but this healing came with new rules. This was no longer the world of the dinosaurs. The asteroid had not simply ended an age, it had reset the playing field. Now, evolution had room to experiment in ways it hadn't in millions of years. Mammals with better hearing, stronger limbs, more complex brains began to emerge. Tiny differences that once didn't matter, like the shape of a jawbone or the length of a limb, now meant life or death. Natural selection worked furiously in the open silence left by extinction. Within a few 100,000 years, a blink in geological time, mammals were diversifying into entirely new forms. The seeds of future whales, primates, and ungulates were already being planted. The ancestors of humanity, though still just rodent-sized scavengers, had begun their long and improbable journey. Still, the Earth bore its scars. Fossil records show cratered seabeds, soot layers embedded deep in rock, and the telltale iridium line, the fingerprint of the asteroid still visible 66 million years later. And though life had returned, one question lingered beneath the roots of reborn forests, whispered in the winds over new grasslands. Could this rebirth, as vibrant as it was, withstand another cosmic accident? If an asteroid could extinguish 75% of life on Earth in a single day, could it happen again? The planet had endured, scarred, broken, and quiet, but not dead. The skies, once opaque with ash and grief, slowly began to clear, revealing the blue above. The silence that had blanketed the Earth after the mass extinction was not complete. Beneath the charred soil and among the smoldering remnants of ferns and trees, life stirred, fragile, determined, timeless. The age of reptiles had ended not with a whimper, but a thunderous collapse. But nature, indifferent and eternal, wasted no time in reclaiming her canvas. The survivors, tiny, overlooked and underestimated, emerged into a world that was now theirs to inherit. The mighty had fallen. The meek would now define the course of Earth's next great epoch. In the shadows left by the vanished dinosaurs, the stage was set for a new kind of life to rise, not creatures of towering strength or armored hide, but of flexibility, cunning, and change. Mammals. Once confined to the margins of existence, hiding beneath the feet of thunder lizards and darting through the night, they were no longer subjects, they were pioneers. The Paleocene epoch dawned not with a bang but with a breath. Earth was healing, slowly, cautiously, and the mammals were already adapting. Their small, warm bodies, once liabilities in a world of giants, had become their greatest advantage. Cold-blooded reptiles struggled in the fluctuating climate of the post-impact Earth, but the mammals could regulate their temperature. They could nest, they could huddle, and more than anything, they could change. In the first million years following the impact, the fossil record shows a remarkable story, one of explosive diversification. What had been a narrow tree of life, with a few shivering branches of mammalian forms, suddenly split and flourished. Tiny insectivores became climbers, gliders, burrowers. They explored every opportunity the dinosaurs had left behind. Every gap in the ecosystem was a door, and the mammals had the key. But what made them so adaptable? It wasn't just their size or fur or ability to bear live young, it was their brains. Compared to their reptilian predecessors, mammals were thinkers. Even the smallest shrew-like ancestors possessed a remarkable capacity for learning and memory. They developed stronger social bonds. Some even began to form early family groups, a trait that would one day become the basis of tribes, societies, civilizations. In the forests reborn from the ashes, mammals began to climb. Not just metaphorically, literally. Some species found safety and opportunity among the branches of new flowering plants. Fruits and seeds became food, tree trunks became shelter, and the world became vertical. Arboreal life offered a new frontier, one never truly conquered by the ancient reptiles. It was here that some of the earliest primates would begin their journey, ancestors that one day would become us. At the same time, on the ground, evolution was experimenting with new forms. Larger herbivorous mammals emerged, some resembling modern-day tapirs or pigs, others taking on the roles once filled by small dinosaurs. Carnivorous mammals began to appear as well, swift, clever, and tenacious. In time, some would grow large enough to challenge even the largest herbivores of the New World. The oceans too were transformed. With the marine reptiles gone, the mosasaurs, the plesiosaurs, the ichthyosaurs, mammals once again stepped into the breach. Within a few million years, certain land-dwelling species began returning to the sea. They became sleeker, more hydrodynamic, their limbs became flippers, their nostrils crept to the tops of their heads. These were the early ancestors of whales, dolphins, and seals. Life had not only rebounded, it had evolved into something entirely new. But it wasn't just the mammals who rose. Birds, the only lineage of dinosaurs to survive, also underwent a spectacular expansion. With the skies now free of pterosaurs and most aerial predators, birds took wing and diversified across every continent. From songbirds to raptors to aquatic divers, their story was one of reinvention. The dinosaurs had not entirely vanished. They had simply traded their teeth for beaks and their tails for feathers. And yet, despite all this change, the Earth remained a volatile place. The continents continued to shift, volcanoes still rumbled. The climate was unstable, swinging between warm spells and cooling phases. Extinction events continued, smaller ones but still disruptive. Every few million years, evolution had to start again, but each time the survivors were smarter, better adapted, more interconnected. Among the mammalian lineages, one group began to stand out: the primates. What set them apart was not just their opposable thumbs or binocular vision, but their growing dependence on social structures. They raised their young longer, they learned from one another, they formed communities. Intelligence, once a luxury, became a tool for survival. And deep in the ancient forests of what is now Asia and Africa, some of these early primates began to descend from the trees. They walked on two legs, they crafted tools, they communicated with sounds. And with each generation their brains grew larger, they remembered, they imagined. But that moment was still tens of millions of years away. For now, Earth was still finding its balance. The mammalian dominion had begun, but the planet was still untamed. Titanotheres thundered across plains. Giant flightless birds stalked their prey. Saber-toothed predators honed their killing techniques in the shadows. It was a world of giants once more, but of a different kind. One built not on raw size or strength but on adaptability and evolution. The Paleocene gave way to the Eocene, and with it came forests that stretched nearly to the poles, a warm Earth, a green Earth, and a world where mammals had now carved out entire kingdoms, some in the trees, some in the seas, others beneath the ground. It was a renaissance of life unlike anything since the Cambrian explosion. But for all its brilliance, this age of mammals was also fragile. A shift in temperature, a change in sea levels, a volcanic winter, any of these could collapse the new order, and they often did. Yet each time life found a way. Each time the mammals came back, stronger, more diverse, more complex. One might ask, why did the mammals succeed where the dinosaurs failed? Was it simply chance? Timing? Or was there something deeper? A trait embedded in the very core of mammalian life. A trait that allowed them not just to survive but to adapt, to outthink, to outlast. We know that without the asteroid, dinosaurs may have ruled for another 100 million years. There may have been no rise of mammals, no primates, no us. But history does not rewind. The cosmos delivered its judgment in the form of fire and ash. And in that darkness something new was born. The mammals did not inherit the earth because they were destined to. They earned it. By hiding in the dirt, by eating anything and everything, by bearing warm young in cold caves, by watching, learning, remembering. The very things that once made them insignificant in the eyes of a Tyrannosaurus, made them titans in a world that needed rebirth. And yet the rise of mammals was not the end of the story, far from it. Because somewhere, in the shadow of great forests and under the gaze of towering mountain ranges, something else was stirring. A lineage that would not stop at survival, but would one day master fire, write stories in stone, split the atom, and dream of other worlds. What was it about that one lineage of primates, so small, so vulnerable, that set it on the path not just to adapt, but to ask questions, to create, to explore, to wonder? Could it be that the very catastrophe that nearly ended all life gave birth to something far greater? Or was it simply nature's way, that from destruction comes innovation, and from the ashes of the past, the seeds of the future always grow? What if the asteroid had missed? What kind of world would exist today? And in that world, would intelligence have ever risen? Or are we perhaps the universe's own way of understanding extinction? The next chapter begins not with an end, but with a question. The world is silent again, not from death, but from the stillness of reflection. The echoes of the ancient asteroid, the one that wiped the slate clean 66 million years ago, still ripple through the fossil record and now, through our understanding of planetary vulnerability. We look up at the stars now with more than wonder, we look with caution, with memory, with dread. Because buried beneath the layers of sediment and time, beneath the quiet bones of dinosaurs and the soot of ancient firestorms, lies a truth so haunting that it cannot be ignored. It happened once, it was sudden, it was global, and it nearly erased life itself. For centuries, the idea that a rock from the sky could end the world was relegated to myth, the stuff of divine wrath or apocalyptic prophecy. But science, with its drills, satellites, and patient observation, has shown us that the threat is neither fiction nor superstition, it's history, and history has a way of repeating itself. Today, we stand on the edge of cosmic awareness, armed with telescopes that can peer millions of miles into the void, and satellites that orbit high above our atmosphere. We have begun to map the realm of near-Earth objects, silent travelers that, in another age, might have carried fire and death. Now, we track them, watch them, name them, but still we do not fully control them. In 2022, NASA launched a mission with a goal once reserved for science fiction. Its name, DART, the Double Asteroid Redirection Test. The objective was as bold as it was unprecedented, to intercept a harmless asteroid moonlit, dimorphos and nudge it, ever so slightly, off its orbit. A cosmic push, a proof of concept, a message sent to the stars. We are watching now. And it worked. For the first time in human history, a species altered the trajectory of a celestial body. A tiny spacecraft smaller than a car slammed into the asteroid at over 14,000 miles per hour. The impact, invisible to the naked eye, was monumental in consequence. The orbit of Dimorphos shortened, the course had changed, Earth had learned how to fight back. But DART was just the beginning. Following its success, NASA and its international partners doubled down. The NEO Surveyor, an infrared space telescope scheduled for launch in the coming years, will expand our vision beyond anything we've achieved before. While optical telescopes can be blinded by sunlight, NEO Surveyor will see heat, revealing asteroids lurking in the daytime sky, hidden in plain sight. As of now, we know of over 32,000 near-Earth objects. Thousands more are discovered each year. Most are small, harmless, pebbles in the void, but a few, perhaps 100 or so, are large enough to destroy a city. A handful could destroy a continent, and fewer still, the true monsters could bring global extinction. Chicxulub was about 7.5 miles wide, a single stone from the sky. Yet in seconds it turned paradise into a graveyard. It transformed lush forests into charred ash, sunlit oceans into boiling cauldrons, and a thriving planet into a planet-sized funeral pyre. We've drilled deep into the earth at the Yucatan Peninsula, into the buried scar of Chicxulub. From those cores, scientists have read a story written in soot and shock quartz. They've found the iridium layer, a rare metal, common in asteroids but almost absent on Earth, forming a thin line in the sediment marking the moment the world changed. They've modeled the impact, reconstructed the blast, imagined the tsunamis, the firestorms, the months of darkness, and they've seen how quickly it all unraveled. All it took was time. A few minutes for the skies to ignite, a few hours for continents to burn, a few days for the sun to vanish, and a few years for 75% of all species to vanish. If that doesn't haunt you, it should. And yet here we are, fragile, hopeful, brilliant, capable of looking back 66 million years and forward into infinity. Today, governments around the world conduct asteroid detection programs. ESA, JAXA, CNSA, ISRO. Space agencies from every corner of the globe now collaborate in what may be our most important shared mission: planetary defense. But detection is only the first step. What happens if we find one? What if a rock the size of a small city is on a collision course, and we have only years to act? Could we nudge it? Could we detonate a bomb nearby? Could we evacuate? Could we survive? The truth is, we don't fully know. Unlike the movies, there is no magical formula, no guaranteed solution. Physics is complex, space is cruel, and time is always against us. The greatest threat might not even be the large asteroids. It could be the smaller, undetected ones, like the 2013 Chelyabinsk meteor, which exploded in Earth's atmosphere without warning, injuring over 1,500 people in Russia. It was only 66 feet wide. Imagine one 5 times larger, over a densely populated city. So we prepare, we simulate, we build observatories and run drills, because we've learned the hard way that Earth is not immune. Chicxulub was not unique, it was just the latest. Our planet's surface is pockmarked with craters, silent witnesses to cosmic violence. Tunguska, Barringer, Poppyguy, Sudbury, Manicouagan, and beneath the oceans, others we haven't even found yet. And so we live in this thin moment of grace between two impacts, a blink in geological time, the calm between asteroids. Some scientists estimate that extinction-level impacts happen roughly every 100 million years. We are 66 million years removed from the last. That doesn't mean we have 34 million years left, it means we're already deep into the countdown. But perhaps, unlike the dinosaurs, we have a chance. We have tools, we have foresight, we have eyes that scan the heavens, and minds that can act before it's too late. The question is, will we? Because the universe is silent, and the asteroids don't care if you're ready or not. In the end, Chicxulub was both a catastrophe and a catalyst. It ended the age of reptiles and began the age of mammals. It set the stage for the rise of intelligence, of technology, of reflection. It gave us a world where creatures could wonder what came before, and what may come after. Now we know what extinction looks like. We've seen the evidence in rock, in bone, in carbon and ash. We've walked through the graveyards of ancient Earth, and read the last pages of lost worlds. We've learned what it means to be fragile and what it means to rise again. But above all, we've learned that space is not empty. It's not just stars and dreams. It's also filled with ghosts of ancient collisions. And maybe, just maybe, another one is on its way. And so we ask, not as scientists, not as storytellers, but as a species, could it happen again? If it happened once, could it happen again? Yes. And the clock is ticking. The planet spins on, the fires have long since cooled, the bones have turned to fossils, the crater has eroded into the sea, the once invincible dinosaurs are now shadows in stone, and yet, their legacy lives on in every bird that takes flight, in every mammal that draws breath, in us. We are the improbable survivors of an ancient reckoning, a lineage that endured darkness, cold, and extinction, only to rise and build telescopes, satellites, and stories about the very rock that nearly ended it all. But for all our progress, for all our brilliance, one truth remains as silent and indifferent as the cosmos itself. We are still vulnerable. Somewhere in the infinite blackness of space there may be another Chicxulub, another rogue wanderer, invisible, unannounced, waiting. Will it come in 1,000 years, 1,000,000, or has it already been spotted, quietly moving through the solar system, its trajectory uncertain? Or more terrifying still, what if the next extinction doesn't come from above, but from within? What if we are now the asteroid? What if the climate changes not by cosmic accident, but by human hands? What if the oceans die again? Not from molten rain, but from pollution. What if the next extinction bears our fingerprints? And if life can be erased so quickly, how many other worlds in the universe met the same fate? Are the stars above littered with ancient Chicxulubs, wiping clean the slate of civilizations we'll never know? Maybe that's the final twist. Maybe the dinosaurs were not the first. Maybe we will not be the last. So the question we leave you with isn't if it could happen again. It's this: when it does, who or what will tell our story? Fade to black, sound of a distant impact rumble, then silence.